Ray Takahashi, and I am a third-year biochemistry student. And today I will be working through Chapter 3.1, Practice Problem Number 1 from the workbook. Okay, so the problem is, how many moles are present in 100 grams of each of the following? And then how many molecules are there? So this is a two-part question, and then there are 4 associated problems with it. So let's work through all of these step by step. So for part A, we are given H2O, or water, and what we first want to do is find the molar mass. Because if you remember back to your lectures, the molar mass, the units for these, is grams per mole. Or you can change it around and say moles over grams. So why we want to find this is because we're given 100 grams of each of the following. So for in this case, water. And then we want to convert this into moles. So notice that molar mass, it has both the units of grams and moles. So to find the molar mass of water, we go to your periodic table, and then we find the masses of hydrogen and then oxygen. So hydrogen is 1.008 grams per mole. And then don't forget to multiply this by 2 because notice in water we have 2 hydrogen atoms. And then we add that with the mass of water or oxygen, which is 16 grams per mole. And then we can add these two together and we get 18.016 grams per mole of water. Okay, so now what we want to do is use that information we're given in this problem, so 100 grams. So 100 grams of water. And then we are going to have moles at the end. So what we want is moles of water on top, and then grams of water on the bottom. So this molar mass that we got, we are actually going to flip it. So we have 1 mole of water and then 18.016 grams on the bottom. Notice when you set this up, you can actually cancel out grams and grams, and you're left with moles on top, which is what we want. So when you do this math, you get 5.55 moles of water, and that is your answer for the first part of this question. So you can't stop there because we're also asked how many molecules are there. So make sure you don't confuse moles and molecules. Those are 2 different things. And to convert from moles to molecules, you want to use that really big number or the Avogadro's number. So what we do is 5.55 moles of water. And then again, like this previous line, we want to cancel out moles. So we are going to have moles of water on the bottom, and then molecules of water on top. So for every 1 mole of water, we have 6.022 times 10 to the 23rd molecules of water. This is Avogadro's number. And then notice again, we can cancel out moles, and we're left with molecules of water. So when you do this math, you get 3.34 times 10 to the 24th molecules of water. Yay! Okay, so I hope that wasn't too bad. So if you haven't already, go ahead and pause this video so you can work on part B, C, and D. And then go ahead and play it again so we can go through these again step by step. So go ahead and pause it. Okay, so let's work on part B. So part B, we are given the compound C6H12O6. This is the formula for glucose. You may see this one in your future biology classes maybe. So, again, like that water example, we are going to find the molar mass of this first. So the molar mass, go ahead and pull out your periodic table again, and then look at carbon, hydrogen, and oxygen. So for carbon, it is 12.01 grams per mole. And then we have 6 of those, so make sure to multiply it by 6. And then we have hydrogen, which is 1.008 grams per mole. And then we have 12 of those. And then lastly, we have oxygen, which is 16.00 grams per mole. And then we have 6 of those. And then when you do your math, we get 180.156 grams per mole of C6H12O6. Now we use the information that we're given in the problem of 100 grams, in this case 100 grams of C6H12O6. Then we are going to use the molar mass that we just found. So for 1 mole of C6H12O6, we have 180.156 grams of C6H12O6. We can cancel out grams, and then we're left with moles, which is what we want. And then we get 0.555 moles of C6H12O6. So this is the answer to the first part of this question. I'm going to move a little bit. Then, to find the molecules, we use Avogadro's number. So we start off with the moles that we just found, 0.555 moles of C6H12O6. We want to get rid of moles and get molecules, so we're going to put the moles on bottom. 1 mole of C6H12O6. Then Avogadro's number, 6.022 times 10 to the 23rd molecules of C6H12O6. Moles and moles can cancel, and we're left with molecules. That will give you 3.34 times 10 to the 23rd molecules of C6H12O6. Box that answer. Yay! So I forgot to mention this for part A for water, but make sure you have units. Well, make sure to always have units when you have units, but in this case, especially to be able to differentiate from moles and molecules, you don't want to abbreviate molecules with MOL because that suggests that you have moles, which are not the same thing, which we actually proved here in math. So make sure to remember that if you and check if you've already done C and D that you have proper units for them. Okay, so now let's start with C. C is HC2H3O6. Because the H's are kind of spread out in this formula, I'm actually going to just change this to C2H4O6, so it'll be easier for us to find the molar mass. So to find the molar mass, again, we go back to the periodic table and we find the masses of carbon, hydrogen, and oxygen. So in this case, we have 12.01 grams per mole the carbon, and we have 2 of those here, plus 1.008 grams per mole of hydrogen, and we have 4 of those, plus 16.00 grams per mole from the oxygen. Then we have 6 of those. So when we do the math, we get 124.052 grams per mole of C2H4O6. Okay, so now we want to convert this grams to moles, so we do 100 grams of C2H4O6 times, and then we flip the molar mass that we just got, so 124.052 grams of C2H4O6 on the bottom, and then we have moles on top. Grams can cancel, and we're left with moles, which will give you 0.806 moles. And then, to find the molecules, we multiply this number that we just got by Avogadro's number. So 0.806 grams. Oh, sorry, not grams. Moles of C2H4O6 times 6.022 times 10 to the 23rd molecules of C2H4O6 divided by, we want to cancel out moles, so we're going to have moles on the bottom, 1 mole of C2H4O6. Moles cancel, we're left with molecules, which will give you 4.85 times 10 to the 23rd molecules of C2H4O6. Okay, now I'm going to box my answers. And there we go. So I hope so far you've gotten to see the pattern. So I'm actually only going to show you the answer for part D. If you're still kind of confused, make sure to go through this video again to find that pattern again. Okay, so for part D, we are given C3H8. So for the moles, you should get 2.27 moles of C3H8. And then for molecules, you should get 1.36 times 10 to the 24th molecules of C3H8. Okay, and that's it. So I hope you found this video helpful, and I hope it answered any questions that you had. Thank you so much for watching.